Good morning, everybody. Today we're going to talk about linear models and scatter plots. Now, you're definitely going to want to have your graphing calculator for this one. Okay, so first of all, let's talk about what a scatter plot is. So, many situations involve finding relationships between two different variables. This can be done using something called a scatter plot, and this is what a scatter plot looks like. Okay, it's just some data on a graph. Now, this one happens to be the scatter plot of married couples comparing the age of the husband to the age of the wife. So here's the husband's age down here, goes from 30 to 80. The wife's age goes from 30 to 85. And you can see that there's a definite line here. Okay? Basically, the older the husband, for the most part, the older the wife. And that makes sense because most people want to be with somebody who is there and has their life experience, etc. Okay, now there's a few that are, this one, the man's pretty old. He's 70 and his wife's about 58 or so. There's always outliers. I mean, I'm sure you can find some that are down in here. But this was, whatever this data was that was collected, this is what they got. Okay, so scatter plot correlations. So these are the different kinds of scatter plots that you might see. This is called a positive correlation. And this one, as x gets bigger, y gets bigger. And it's pretty linear, okay? It looks kind of like a line, or it forms around a line. This is a negative correlation. Okay, so as x gets bigger, y gets smaller. This would be something like your age versus how many years you have left to live, I suppose. So this is also kind of linear. Now this is obviously not linear, this is parabolic. Okay, so this is a parabolic correlation. This could be something like the population of a town that had a gold spike. Okay, so there was hardly any people that lived there. And then they discovered gold, and the population increased, and then the gold ran out, and then the population decreased. Something like that. This is a cubic correlation over here. This could be something like population of a town. And they build a military base, okay? So then as the base gets filled, the population goes up to support the military base, and then maybe they close the military base. So then the population starts to drop. But then they convert that base into something else, like maybe a university. And then the population starts to go back up again because you've got to have people supporting that university. I actually know of a town where it went just exactly like that. It was in California. Okay, this right here, this is exponential. Okay, this is what you want your bank account to do. Take off and get big fast. All right, what's this thing? Okay, this crazy thing here, this is no correlation right here. Now, what has no correlation? No correlation. How about the number of assignments that I get from my math teacher compared to what I had for breakfast this morning? There is no correlation between those two things, and so it'd just be scattered. Now, the interesting thing about this is sometimes, as you get more data, and you kind of back out and look at a bigger and bigger thing, this might be a linear thing, which is why when you're doing studies and stuff, you need to have plenty of data. You can't just look at a couple things. You You can't say, oh, I want to know what everybody's favorite movie is, and I ask 5 people. Because, that's not enough data to get anything good. You might have a total scattering. All 5 people might like something totally different. But if you ask 500 people, it might lead you in a certain direction. Okay, in baseball, the on-base percentage for a team represents the percentage of time that players safely reach first base. The data in the table below represents the number of runs scored Y and the on-base percentage X for teams in the National League during the 2003 baseball season. So, here's your teams. Here's your on-base percentage. Okay, look at that. The best one was only 35%. Number of runs scored. Okay, you can see as the on-base percentage decreases, the number of runs the team scores also decreases. Now, it's not a perfect linear thing, but there's definitely a correlation there. So this would be a positive correlation because the higher your on-base percentage, the higher your run score. Okay, so how can I draw a scatter diagram of this on my calculator? All right, here's what you're going to do. You're going to turn it on, and you're going to want to push let's see. Oh, the first thing you're going to want to do is clear the list. So you want to make sure there's nothing in there. So go second, and your plus key right above that says MEM. That's your memory. And you're going to choose number 4, says clear all lists. And then you're going to hit enter. Okay, so you've cleared the lists out of this thing so that there's no data in there that's going to mess with your deal. Now, next thing you're going to do is you're going to push your stat key. It's 2 over to the right from your green alpha key, and it's going to come up and it's going to say edit, calculate tests, and you're going to stay in edit, and the first one says edit, so hit enter. And you want to make sure you're in L1. So you got these lists. You want to be in L1. Okay, so if you're not arrow over there, there should be no data in there because you've cleared the list. And we're going to put our X's in there. Okay, so 34.9, enter, 35, enter, 34.4, enter, 33.6, enter, 34.3, 33.8, another 33.8, 33.3, 32.3, 33, 32.9, 32.6, 31.8, 33.3, 31.4, and the lowly Dodgers, 30.3. Okay. Now you got to be careful that they're all in there correctly and that they're all in there. All right, now we're going to arrow to the right and we're going to be in list 2. And what we're going to do is we're going to list the runs here, and they have to be they have to be paired up with the same one for the X's. So I got to do them in the same exact order. 907, enter, 876, 853, 805, 791, 755, 753, 751, 724, 717, 714, 711, 694, 678, 642, and 574. Now, it's a really good idea to take a look at your 2 lists and make sure they're the same height. There's not one extra one in one column or the other, because if you do that, your data is going to be all messed up. Okay. Now you can quit there. All right, now we got to adjust our window, because the window that I have, go to y equals, if there's any equations there, clear them out. All right, what am I doing here? There we go. Okay. Okay, so we're going to adjust our window. Now, what do we need our window to be? Well, we want it to go from, we're going to look at the x's first. We want it to go from below 30.3. So we'll just put in 30 for our x min. And our highest is 35, so we'll go to 36. Now, how do we want to count? So we could count by 0.2. I think would be fine. You don't want to go too many more than that because you'll have too many dots on your graph to read. Okay, now our y's, we're going to go from 550 because we want to be below that to 950 because we want to be above 907, and we'll count by 50s. Okay, now I go ahead and I hit graph and nothing happens. Why didn't anything happen? Because I did not turn my plots on. So here's what you're going to do. Push your blue second key and then your y equals. And it says stat plots. Okay? So you're going to hit, it's going to be, the first one's going to be highlighted. Just hit enter. And you need to turn that on. So you're going to go to on, you're going to click it on. Now you can see under type, there's different kinds of graphs. You want the scatter plot, which is the first one. And it should say X list L1 and Y list L2. And then you have a way you can choose different marks, okay? There's 3 different marks in there. I would not choose the small one. It's really hard to see. I would choose the largest one. Now, if I had hundreds and hundreds of pieces of data, you might choose the smallest one because it'll fill all that up and you can see it better. So just hit enter and quit. And now hit graph. And I get a nice graph, okay? And it's going to look kind of like, it's going to look kind of like this. And there you got a scatter plot. Now, we can do all kinds of things with that data once that's in there, but we're not going to learn that today. So you basically have to know how to create a scatter plot on your data, and it should look, I don't know if you can see it, but it should look something like this, and you're off and running. Okay, so what do we got here? These are some different scatter plots. These are pretty cool. This is a 3-dimensional one. I think this one is on stars. And it has to do with the color of the star and how hot the star is and the mass, and it's got all kinds of things on there. Some other different kinds of scatter plots that you can do. They are pretty cool. Okay, so you only got a few problems to do today, but there's 5, 6, 7, 8 problems. And here's your assignment, and I will see you next time.